Hello everyone, welcome to the first video about the Py-EVM. In this series of videos, we're going to go through the Py-EVM and we're going to go edit some source code and print out real-time logs. The way we're able to do this is because we're able to run a Python file and create a blockchain, run it, and then end it. We can create a live blockchain, but Py-EVM allows you to run a blockchain with a simple file, and we can then go into the source code and print out values in real time. So that's what we're going to do right here. I'm going to take you through the application we're going to simply run in all the following demos. I have all the comments printed out except for the log message, the initial one. So this could be a very simple one. So we're going to define our Genesis block parameters right here. We're going to create a private key for our sender because we're going to send a transaction in this example. We're going to create an address for the sender since it's going to be the first canonical address in this blockchain. It'll be x01. We're going to be sending some ether to x02. So we have a mining chain right here. This is going to be our proof of work validation, everything like that for our transactions and our blocks. And we're going to, sorry about the jittery screen. Then we're going to create a chain right here from the atomic DB. So we're going to have, there's multiple databases we can use. We're using atomic here. We're going to use Genesis parameters, which we defined above. We're going to call it Genesis right here, set it equal to the first block of the chain, and we're going to create the chain and set our current VM to the chain VM that we just created. So when we send a transaction, we have it nonce for the sender. This differentiates between pending and queued transactions. We'll go into that in the transactions demo later, and we create a unsigned transaction here. In the transactions demo, we print out the raw transaction and the signed transaction, see what things get applied. And the proof of work, something else also happens there, which you'll see in the demo. Then we apply the transaction, so that's the proof of work part of the transaction right there, the validation. And then we're going to set the header for the block because when we say there's no more transactions, it's going to start saying that we're going to start forming a block. So then we're going to create from the chain VM, which we defined above. We're going to finalize a block. So we're saying no more transactions can be added to this block. And then we're going to say the block result. This has some proof of work stuff in it too. And we're going to say this is what the block is. And then down here, we're going to get from that block we just created a nonce and mix hash for our proof of work algorithm that we're going to do when we validate the block. And we did a proof of work validation right here, and that we'll go through that in the proof of work demo as well. But this is just the main app that we run. We run the app, and we can recreate it. That's the beautiful thing about this. The values will always be the same if we run the same app, so we can always trace back and then map things throughout everything, which is very, very convenient because since the values stay the same, it's not a variable, it's more of a constant when you go to debug, which is really nice. But so this is how we just run the main app. It's just a Python 3 app. And in the write-up I have how to create an app like this. And we have that simple welcome to the Py-EVM logger that I have printed out. So the program runs, and we'll see in the following demos how everything is tied together. But I hope you stay tuned, and thanks for watching.